Hello out there. Welcome back once again. We are still on statistics, and I hope you're enjoying out there and you're working hard. And remember, consistency is the key. Okay, so what are we going to look at now? In this segment, we're going to look at what? Our scatter plot. What is a scatter plot? Have you seen a scatter plot before? Okay, it's a scatter plot with just representation of data of an independent and dependent variable, which is x and y coordinate in the first quadrant of our Cartesian plane. Okay, that's how we're going to draw our scatter plot. Okay, let's see how we do that. So there's a scatter plot. So here I have size and weight or mass, okay, of a person. So that's the shoe size and how much they weigh. So the data was collected, okay? So as a survey implies we went to people, what is the shoe size and what is the weight? Found that the shoe size was 5 and the weight was 65 kilogram. And shoe size was 12 and weight 97. And another person, shoe size, which was 7, weight 68. Another person also you can see there was shoe size 10, weight 92, and so on. By looking at this, can you say, is there a correlation between shoe size and weight? Think about this. Okay? Size 5, 65 kilogram. But also look at that. Size 6, 74 kilogram. Okay. Let's see how. How do we represent this on a scatter plot? So we're going to start with 5 and 65. Size, which is shoe size there, is independent on the x-axis, and mass in kilogram as dependent variable on the y-axis. You can see that. And remember to choose your scale, especially if you're not given a place where you draw your scatter plot, okay? Scale is very important, okay? So where this would be my x and this would be my y, okay? So let's see what we do with this. So 5, if x is 5, y is 65. Then I put that as a point. Are we together? On my Cartesian plane. Let's look at the second point. When x is 12, what is y? 97. So we have 12. 12 is there. We have 12. And 97 is between 195. Okay? 12 and 97. There's the point there. Okay? So we already have 2 points. Based on this, can I say, is there a correlation? Can you see with 2 points, I cannot really make a conclusion because I can draw a straight line passing through those 2 points. But can I conclude that, is there a correlation between size and mass? That's why it's the importance of having a large data before you make a conclusion. Because with 2 points, I can draw a straight line. And for me to conclude that there is a strong correlation, that's not really good. With large data, we actually make better, we get better results. Okay. Let's look at the third point. So shoe size is 7 and mass 68. So the shoe size is 7, 68. 68 is between 65 and 70. Okay, let's see what we get. There's the point there. We have 3 points now on our scatter plot. With 3 points, is there what kind of correlation with 3 points? Is it a good thing to use 3 points? No. Because with 3 points, that we can get misleading results with more, we need more data. That looks fairly like strong positive correlation, okay, if I assume 3 points. But let's put more points. Size 10, mass 92. This is what we get for size 10 and 92. If you go back, we get 92. So now I'll put all the points, 10 and 78, 9, 78, the same thing, 8, 76. If I put all the points on my Cartesian plane, let's see what we get. This is, what do we get? All the points represented. This is our scatter plot. Okay. If you look at our scatter plot, what can you conclude about the correlation? Is this a negative correlation? Definitely not a negative correlation. I cannot say there's a negative correlation because points going, I can draw a straight line with a positive gradient. A negative correlation if I draw a straight line with a negative gradient, okay, slope. By looking at this, okay, so can you estimate the value of correlation? Remember we said correlation is between -1 and 1, where 1 is perfect, positive, -1 is perfect, negative correlation. I would say this is strong positive, close to 1, maybe 0.8, okay? Are we together, guys? I hope this makes sense. Now, what are we going to do, guys? I would like us to play with the simulator. What is simulation? Have you heard of the word called simulation? Let's look at what this looks like. Let's see what we have here. So we have our x-axis, independent variable, y-axis, and the correlation coefficient. So simulation will depict the reality. Let's look at what reality we want to depict here. So let's look at height versus shoe size. Height versus shoe size, the data looks like that. So this is the shoe size, and this is the height. So we can see that the points are close together. If we draw a straight line through those points, okay, we can see we're going to get what? A positive gradient. Let me see that. We're going to get a positive gradient. I can try something like that. This is my y value. You can see that. And this is the gradient. Let's move there, somewhere there. And this is my something of that nature. Okay, not perfect. But by looking at that, can you guess the correlation coefficient? Is it a strong correlation? Correlation, we know, is from -1 to 1. What is the value for the correlation for that? I think it's, should I say 0.5, 0.6? Let's see what does this give us. It gives us actually 0.85. It's actually strong positive association between the height and the shoe size. Okay, does that make sense? Great. Let's look at our own simulation, which you're going to do. So let's look at that. Here, what I want to do, I'm going to take points, put them on a Cartesian plane. Okay, look at what is happening to the correlation coefficient value. Okay, let's look at that. It's getting smaller. Why is this getting smaller? Okay, let's look at that. I'm putting more points on the Cartesian plane. Great. Is there correlation here? Definitely. There's no correlation. And if you look at the value, the correlation is 0.114. It's close to 0. Remember that 0 correlation is no correlation. So this is a weak correlation. Are we all together? It's a weak correlation between that. Even if I have to draw a line, I mean, can I draw a line It's quite difficult to find straight line for that, you know. I mean, if I do that, you know, it's quite, I can't find one actually, sure, for that. But what if I want to increase the correlation for these 2 points? What can I do? Actually, let's see if we move, look at, I'd like you to focus on the correlation. Now is 0.26. I'm moving the points together, close together. Look at that. Look at that. What is happening? Let's look at that. Let's look at it. Now it's 0.5. Look at that value. Moving this, 0.99. That's actually strong correlation, because for perfect has to be 1. But by moving this, what is this point? Look at this 1 point. How can this point change the value of correlation? All the lines, all the points, they can actually form a straight line. But we only have 1 point there. That point, let's look at this point, which I'm moving around. And this is actually making the correlation to be close to 0. What do we call this point? It's an outlier. Look at the impact on a correlation, so huge. This is 0.18 by 1 outlier. Let's move this back together. Let's move it somewhere there. Nice, 0.99. I can get a nice straight line. Let's look at this. I can get a nice straight line with a positive gradient. That's my straight line. We can see that there's a strong positive correlation, which I can get from there. Okay, guys, hope this makes sense. Okay, and for us to get a perfect correlation, what must happen? Actually, all the points, they must be on a straight line. Let's see if we can get this close to 1. If I move this there, move that point on the line, move that point on the line, move that point on the line. This is on the line. I'm moving this. Okay. If I move that, not changing, still 0.99, 0.99, 0.99. Let's move this one. Okay, actually quite difficult to do that. Okay, let's see. So I have to move this. Yeah, almost. Look at that. I'm getting R is 1, which is a perfect correlation. Okay, but I can see there's still 1 exactly not on the line, but I'm getting a perfect correlation. Okay, fantastic, guys. I hope this makes sense and you really understand what is happening here. Okay, so now what we have looked at, we've looked at univariate data, we looked at bivariate data, we looked at correlation, and we looked at the scatter plot. Okay, I hope this makes sense and you really understand. Okay, then from there we looked at our statistics, and this is the concept we looked today. Okay, I hope you enjoyed. Okay, this is the end of our lesson, and we hope to see you soon. And remember to keep working hard. Okay, we hope this makes sense. Okay, you keep working hard, take your textbooks, try some of the problem, read a little bit about correlation and this scatter plot. And we hope to see you soon, and enjoy.